Welcome to Study Loop.
Okay, so we are tasked, start from cyclohexanone, get to this fancy product. Well, it's best to think of, how can we get from here to there through a retrosynthetic analysis? So how could we get to this product with just one step? I see that this could have come from a Michael addition of acetone to cyclohexanone. Then that poses a new question, which is how can we get cyclohexanone from cyclohexanone? I don't think that you can get there directly, but my idea is perhaps we can do an elimination reaction to access that. So what if we had a bromine on this position and then used some strong base to deprotonate here and generate our alpha beta unsaturated system? Of course, we can get the bromine on that alpha position just by using a brominating reagent like NBS. So with that strategy in mind, first we can use NBS, and then sodium hydroxide to access our cyclohexanone. And then our cyclohexanone can react with acetone in ethoxide and ethanol in order to generate this Michael addition product. That's not the end of the fun. They also have a part B. So in part B, also starting with cyclohexanone and ending with this arguably more complicated product. So there's 5 new carbons which were attached here. Is that right? 1, 2, 3, 4, 5. Again, sorry, not that last one. 5, that one. So I'm thinking perhaps this last methyl could have also come from a Michael addition in the same way that the previous reaction had a Michael addition. So that would mean we have this unsaturation plus this cuprate, which could add, of course, in a 1,4 conjugate addition manner. And then the question is, how do we get to this fused cyclohexanone? Well, of course, this is coming from your Robinson annulation. So that's actually your ketone at this position and your Michael acceptor at this position. So this is acting as your nucleophile, attacking there. Of course, this comes back around, this attacks there, and you lose water to access that. So this is actually a 2-step reaction mechanism to go from your cyclohexanone. First step, we want to toss in our Michael acceptor, sodium ethoxide, and ethanol. That will get us to this fused system. And then we can just simply add our cuprate with an aqueous workup to protonate off, and that'll get us to our desired product.